Okay, then let's get started. Thanks for joining this technical steering committee meeting. Today we look at a proposal from Plamen, Victor and colleagues about autoscaling persistent volume claims. As usual, we split the time as follows. In the first 10 minutes, Plamen or the authors can reiterate the key aspects of the proposal. And we have a big block where we can ask questions, clarify things, and provide feedback. And the final slot will then be for deciding what to do next and how to proceed. Okay, then let's get started.
Okay, so let me share my screen. So should be like this. Okay. First is the size okay, or should I
maybe increase it a bit? Yeah.
Yeah. Okay, maybe like this is probably better.
Yeah, fine for me.
Okay. So yeah, first I will go over the table of contents, what I will try to present in the first 10 minutes. So of course, the motivation for autoscaling persistent volume claims, especially in Gartner, and why we want to create this separate PVC autoscaler controller for this purpose, or why we want to extend the already existing one. What is our proposal? So the core concept, the example API design that we want to implement for autoscaling PVCs declaratively, the scaling algorithm that we will use, a brief overview of the architecture and how we plan to integrate it into Gartner. In the end, we'll see if we still have some time from these 10 minutes to also go over some of the impacts and alternatives that we managed to find along the way. And of course, some risks and downsides as well. Okay, so what is our motivation to do this? First, the problem, of course, is that, as you know, Gartner deploys persistent volume claims for the Gartner namespace, so for seed components, the Gartner cluster, and also shoot in the shoot control planes, which are all static sizes, so they are configured with the same size for all clusters, which could cause under-provisioning risks for growing or large clusters where we would have log retention or observability signals retention days of maximum of 2-3 days, which can be very problematic when we try to do root cause analysis or other reasons. And on the other hand, for small clusters or relatively short-lived clusters, we over-provision volumes, which could be only utilized to 10% of their full capacity. So this generates a lot of costs. And if we want to resolve this manually, it's a lot of overhead because operators have to edit PVCs directly, which is of course problematic because you also have to manually find the PVCs that belong to a particular workload. For stateful sets, it's easy. But some other components might manage their PVCs not via stateful set. For instance, the VL single that we plan to also add for the observability stack. There are also, adding to this, there are also other PVC controllers that do not offer a very well-designed API because they rely on manually annotating persistent volume claims so that they are reconciled, which is not ideal. Of course, why this matters, as I mentioned, storage costs. On one side, we could save for under-provisioned clusters, and then we could increase the storage of larger clusters so that we retain observability signals for longer. So we would essentially move volume capacity from places where we don't need it to places where we do. And this is very easily solvable with automatically adapting the size of PVCs, and of course automatically also identifying the PVCs that have to be adapted, which is what the proposed controller will do here. Benefits from all of this, Gartner operators, of course, obvious reasons, end users who no longer face issues caused by missing observability signals, and stakeholders who can benefit from the cost reduction in some cases. Yeah, we also here, I think I would mention that we also plan to eventually offer this PVC autoscaler to stakeholders as well, so they could even see a larger benefit for the PVCs that they create themselves in their shard clusters. Okay, then I jump to the proposal. Basically, the idea is to extend, to enhance the already existing PVC autoscaler to now reconcile a new custom resource definition, which will autoscale persistent volume claims. We call this new CRD persistent volume claim autoscaler, and we take heavy inspiration from vertical pod autoscalers and horizontal pod autoscalers, which are already very wide used APIs for scaling workloads. One, of course, for scaling resources in containers, and the other one, replica sets. Okay, now let me briefly go through the API. So again, as I mentioned, similar to VPA and HPA, we specify a target reference where with this CRD, you can target a workload controller directly. So for instance, here, it could be a Prometheus, but of course, this could also be a stateful set or deployment, or yeah, anything else that could support selectors. So similar to VPA and HPA again, we use the scale subresource from which we could find label selectors. And then we use these label selectors to find pods that belong to this controller. And from those pods, we can then select volumes which have to be autoscaled. So since we can select multiple PVCs, we have this volume claim policies array, similar to container policies, which allow you to specify more concrete settings on how you want to autoscale a particular PVC. Because we imagine here that there could be some workloads where it could have PVC that's used as a main storage, for instance, for a database, but also some smaller PVC that could be used for cache or some other functions which might not need to be scaled, or might need to be scaled to a lesser amount. So to that end, we have constraints, max capacity, min capacity, pretty self-explanatory, a match selector, which allows us to the scale section. So yeah, maybe a forward. This here kind of looks similar to HPA. The main reason for that is that the algorithm that we want to use is a simple threshold-based algorithm. So this would mean, let's say that you have configured this threshold % of 80. So if the currently used bytes or currently used inodes go over this threshold %, then we would scale up the PVC. The PVC would be scaled by either 25%, or this mean step absolute, which is basically whichever of those two offers the larger increase will be used. So we need this on some particular providers where scaling for PVCs can only occur once every 6 hours. For instance, on AWS, where we plan to have this min step absolute configured to a larger values so that we can accommodate this this reason that we might not be able to scale as frequently as we want. The strategy is something that we want to add later on if it's necessary. So at the end of the document, there's a more detailed rollout plan. But yeah, the strategy is a field that indicates how these updates to the PVCs are done. In place means that we will directly bump the capacity size in the PVC. Evict pods if necessary is a strategy that's again required due to some provider restrictions. For instance, Azure, we found out that on some VM types, you cannot directly finish resizing of a PVC if the corresponding volume is still attached to a particular VM. So the pods need to be evicted for the volume to be detached, or for the volume to be not active. And then once the pods become active again, or once they are recreated, the resize can actually finish. Then, scale down is similar to scale up, with one big thing that I want to mention here, that scale down is actually a lot more complex to implement than scale up. It's not natively available in Kubernetes. So we've mainly added it here as an information on what it could possibly look like, but we would actually want to postpone implementing scale down as much as possible. Maybe even, not implement it unless there is very, very high demand from stakeholders. The reason for that is that you could only use rsync. So there's also no native approach other than rsync on cloud providers. Or you have to delete your volumes and potentially have an admission webhook that updates the PVC to a smaller size only after the PVC and the volume have been deleted. Actually I added this here just as a hint on what could potentially be done, but I think the only viable strategy, for instance, here is rsync, or to turn it off. And this is actually a good place to mention what this strategy of off means. This means that we will not do any autoscaling directly. We will just post the recommendations in the status, and then another controller could do the actual modification of the PVCs. This is similar to VPA, where you could turn off scaling and only post recommendations in the status of similar to VPA, where you could turn off manual scaling and only have the recommendations part of the status of the VPA resource. Conditions, pretty self-explanatory again. A condition telling us whether something is being resized currently and the reason why it is resized, for instance, inodes or size, whether the recommendations are available. So this means whether we have identified PVCs that belong to this, the target that we are referencing, and whether they have metrics, whether we have successfully fetched metrics for them. And then an array of persistent volume claims in the corresponding current size and target size, which is kind of like the recommendation. And some additional information here. So I think this also kind of covers some of the key features, as I mentioned: automatic PVC discovery, volume-specific policies, scale-up capabilities, at least initially. We will add some metrics that I do not want to go into detail here now in these 10 minutes. And as I mentioned, for the scaling algorithm, we decided to use a simple threshold-based approach. So this is different to what VPA does. What VPA's algorithm is very complex. And it kind of is useful when you have random spikes, for instance, CPU and memory. So I don't think it's too applicable for storage. Downscaling, again, as I mentioned, it's very brittle. It's very hard to implement because it requires safe data migration, coordination with the application, downtime. There might be some specific for each particular application on how it can actually downsize or how it manages its PVCs. And as I mentioned, no Kubernetes native way, because volume snapshots, for instance, which was one of the things that was proposed at the start to be used as a downscaling strategy, does not work, because you cannot create a PVC with a smaller size than the size that was used to create the volume snapshot. Briefly, the architecture, I think the main thing to point out here is that currently metrics are retrieved from Prometheus, which scrapes them from the kubelets metrics endpoint. This is for Gartner. We plan to use the cache Prometheus here directly. In the future, of course, this might have to be changed for when we offer this to stakeholders, but we should probably leave these discussions for later on. Once we have already implemented this in Gartner, we can see how to modify fetching metrics to also be able to be fetched from the proxy of the API server, or if it's running in the same cluster to fetch them directly for kubelet. But for now, Prometheus just seems like the better approach. It's very simple to implement, mostly reliable, and on how we plan to integrate it into Gartner. Here we wanted to mostly focus on how we will
I'm not sure if you saw the message, but the time is running out, done. So maybe finish within a minute or so.
Yeah, this is actually the last one. So exactly. The last one thing that I want to mention, the Gartner, it will be deployed as a Garden component in the Garden namespace with these extensions to the seed API. So there will be a new section in the seed settings allowing to specify some boundaries due to these cloud provider limitations that I mentioned on AWS, for instance. And of course, during reconciliation of shoots or during reconciliation of seed, we would automatically deploy these PVCA resources for each workload, and the PVC autoscaler can directly start scaling them without any additional changes. I guess, well, the only additional change that we want to do is to reduce the initial sizes of such objects so that we can start scaling up from lower values due to the fact that we do not support scale down as in the initial version. So yeah, I think this is it. I also mentioned some of the risks and downsides while I was talking about this. And yeah, maybe we can then start the discussion.
Yeah, great. Thanks for reiterating the key aspects. Then let's go to the second part, questions. Anything that needs to be clarified?
First of all, I would be interested in knowing what is already existing. So you said the PVC autoscaler is not an entirely new project, and what your experiences are with it.
So yeah, PVC autoscaler, it was already created, I think, last year or maybe even before that. However, as I mentioned, I mean, it works as you expect. It successfully scales PVCs. The main problem with it was that to actually start scaling PVCs, you had to annotate them with these fields that we have now exported in the API. So you had to manually go and for existing PVCs, put the annotations. So yeah, find these PVCs and so on, which is somewhat manual work, so not ideal. And then the other problem, of course, was that if you want to do it in a better way, you would edit, for instance, the PVC templates in stateful sets, which is also another way to do it. But for existing stateful sets, PVC templates are immutable, at least for now. So this is also not possible to do for existing stateful set. But otherwise, as I said, the scaling algorithm is already there. The reconciliation logic is already there. We plan to reuse that. So yeah, mostly what just has to be done is the start using the new API. And yeah, I also want to mention that so in the past months, we were actually working on this repository. So it's now also integrated with PRAL. There are actually end-to-end tests that are already running on PRs.
I was also wondering about, sorry, go ahead.
No, go on, Tim.
I was also wondering about the IOPS consequences of scaling volumes. If I remember correctly, on some cloud providers, having a bigger volume means more performance. What are your thoughts on that?
Yep, that's true. So this is something that I consider but didn't want to complicate the additional API, not the additional, but the initial API too much with things like that. So this is, for instance, one thing that's already exposed in the seed settings, where you could configure your minimum volume sizes. And we could also reuse this if we find that the reduction of volumes is not sufficient due to IOPS size on all cloud providers. And the other thing that I was also considering is, so for HPA, you actually have exported, not exported, but in HPA, they have a way to specify the metrics which they want to use for scaling. So yeah, a potential future development could be adding something similar. If you want to, let's say, depend on such IOPS to increase your size, you could have this additional metric source part of the API that yeah, lets you check, okay, if I have not enough IOPS, then please scale up and so on. Yeah.
But IOPS is sometimes difficult. You'd have to do it in the storage class. So that would be a completely different concept then.
I mean, yeah, this is why we didn't want to. We didn't think actually too much on that, and we didn't want to include it in the initial API.
So what you're saying is that if we know a particular component needs a certain amount of IOPS, we just set a min capacity to ensure we get the performance we need by trading performance versus used storage.
Yep. And
Okay.
there's also the thing that so if it's a low size anyway, and it doesn't get what I mean for small clusters, you would potentially not also need too much IOPS, right? Because you would expect that there are not many observability signals, at least for when talking about Gartner in particular. So you would probably not need to increase it due to IOPS anyway.
Okay, completely different question or different angle to it. I think my understanding is that our main focus is to use it basically for Gartner in the seed and runtime cluster first to get more experience with that. You also noted some graphs how usually logging stack or the Prometheus persistence scales up. As you also noted on some cloud providers, you cannot really scale up that much. What is your expectation in general? How often would you want to scale? Would you generally want to scale in very small increments? And then on AWS, you have to break that down basically to the 6-hour boundaries, or is the expectation generally that the component will idle most of the time and only rarely, even on a full seed cluster, do something because it just takes a long time until something fills up?
Yeah, so one thing we plan to still investigate this a bit more. This is why Victor now started also looking into adding dashboards for how exactly the PVCs are utilized on most of the components. But in general, I would say that we would probably have different settings for control plane observability components and the ones in the Garden namespace, because the ones in the Garden namespace, they usually fill up faster, I would say, especially for bigger seeds. So there, my recommendation would be to either have a lower threshold and maybe also increase by a larger amount. It's something that we have to play around. To be honest, I do not have. My gut feeling would be that, for Garden cluster, we use some lower thresholds, or maybe around 60-70%, and increase by a larger amount. Whereas for control planes, those values would be reverse. So higher threshold, maybe smaller amount. But again, it's kind of like VPA, where we have to touch here and there after deployment or a bit before that. Sorry for not having concrete numbers right now.
No, that's completely fair. What I kind of want to understand is because you also added here a proposal for extending the seed settings, will that then be basically imply that the operator of the Gardener landscape needs to completely fine-tune this on his own, so to understand how big are my seed clusters, how big are my control planes, how much are they filling up, and then figure out how the values should go? Or is it basically something where we assume, or at least my understanding for VPA, you can also turn the knobs around, but you can also just deploy VPA and it does its thing. So how is the PVC autoscaler meant to be, or what's your expectation? Do we have just a lot of knobs and we can run everything, but then the operator really has to invest a lot of time, or do we automate a lot more?
Yeah, I think at least my intent was to only have this for particular providers. So not on seat per seat level, but provider per provider level. So let's say for all AWS seats, we have this configuration. For all other seats, we maybe don't have this. And this, as you say, PVC Autoscaler figures it out from the default settings.
If I'm not mistaken, those settings that are on the screen, they're like upper and lower bounds. So as Plamen said, some providers may make sense. For example, AWS has this cooldown on scaling. So an easy way to set it up is through the seat settings. So back to your question, I think the intent is even if you skip all these seat settings to work, just some specific provider stuff to easy way to handle it. For example, as we said, AWS is for the cooldown duration to be specified at that level.
Yeah, makes a lot of sense. I think I'm coming from the direction that we hear from new Gardener users in terms of new Gardener operators, that we already have a huge configuration surface. And I mean, we are extending it here. And the question is now something where basically for us, as we are full into the topic, we can configure that, and everybody else has no idea and it's not working for them, whether we try to build a one solution fits all sizes or not. I mean, it's usually a trade-off. It's usually something in between. So I guess I understand the point. It's just a little bit trying to understand where you're going.
Yeah, makes sense. The intent is for nothing to specify and still in the majority of cases to work. Only those specific details that are provider specific. For example, as we said, the cooldowns, only them to require those and other niche cases. But in general, this should work on most of the cases, or yeah.
If there are provider specifics, settings like the cooldown duration, would it make sense to build that into the provider extension, so that Gardener operators running AWS seats don't need to specify all of this again and again on their own?
Yep, that's so this is something that we consider to actually not have it in here. The reason we did end up doing this or proposing this is because there is already this setting for, so it's not part of the settings in the seat spec, but it's a special field called volumes, which lets you specify the minimum volume size for a particular seat cluster. And for instance, we already use this for AliCloud clusters, as far as I know, to say that the PVCs deployed by Gardener are only 20 gigabytes on this.
The reason why this is in the seed API is because the PVC autoscaler needs to have this information when it starts to scale volumes, right? So it runs in the seed and it needs to know what is the maximum capacity, for example, or what is the cooldown duration for AWS. And the seed API is basically the API where it fetches this from.
Yep.
If it was in the provider extension component configurations, then it would need to fiddle it out from there. I don't know if that's what we want.
Yeah, I mean, it's probably not impossible, just a lot harder to, I guess, get it from another resource.
But if the concern
I was
is
thinking about a webhook to mutate the PVC autoscaler object and directly set these values in there, just like Gardenlet would do, right? I mean, the PVC autoscaler doesn't know about the seed object, but Gardenlet will just deploy the objects with the spec considering the fields from the seed spec.
But in a way, we kind of make this an implicit dependency. I mean, then every provider's extension has to kind of be aware of this PVC autoscaler components that potentially could be modified. So I think this brings, in a way, a different dimension of complexity.
Yeah, it's true.
But do we expect folks to need configuration here other than just the reason of having a provider that imposes some rate limits like AWS? So if we say it's always the same on AWS, but other than that, it doesn't need any specific configuration for a seat, then it would make perfect sense to put it into the provider extension so that folks can just use it off the shelf without even thinking about the rate limits of AWS.
I mean, on the other hand, the most of the code is anyway in the Gardner repository. So if the webhook is there, it's still kind of okay, I guess. Or yeah, if only AWS needs it, only adding a dependency to AWS might also be okay. But yeah, I mean, I think it's a good suggestion. We didn't think of the webhook approach.
Also, it's a trade-off if we want to have provider-specific code into the general repositories, or do we want to export it and make it more configurable? Because that way we kind of put a provider-specific code that we have to maintain. Anyways.
Vedran, do you also want to add to this or something different?
Similar, yeah. But one step back, you discussed the seat. Just for clarification, so you looked already into all cloud providers, and you are certain that you will not need any cloud provider specific logic. You hope that with the fields like cooldown, you covered everything. Okay, so you did that analysis. Then I have only one. Then I would have another follow-up question, and that is, what happens if the operation fails? Let's say you're running out of quota, or the resizer has a problem. Are you rolling back? Are you retrying? Are you differentiating between retryable errors, not retryable errors? So what happens if something bad happens?
Yeah, that's actually a problem that kind of depends on the CSI resizer. Because the only thing that we do is we increase the... So yeah, if we can't increase the capacity of the PVC autoscaler, we, due to some API error or whatnot, we just reattempt to do it until it's increased. But then after we increase the capacity of the PVC, it's up to the resizer to actually finalize the resize of the persistent volume, right? So the only thing I guess we could do at this time is just report the current status of the resize operation.
Is there technically something you could do? So if you see that something is wrong, then probably you cannot resize it again. Make it roll back is not possible. Okay, so it's broken then.
There is a feature in Kubernetes, but I think it's relatively new that allows you to roll back resize operation, if I'm thinking about it correctly right now.
Yes, I think there is a detail about it, and it's maybe you cannot roll back to the exact previous. In a way, it's
no, you can.
Try to,
so basically with 134, that's why I presented it a couple of weeks earlier. In 134, there's a feature: if the expansion fails, you can go back. You can shrink the volume to something that is bigger than, or bigger or equal, I'm not sure, than it was before. So basically, if you go from 10 to 100 and it fails, you can go to 15, and basically retry the expansion. So that could then be possible. But that's as Plamen mentioned, it's newer features. I mean, we have to think eventually it makes sense. I mean.
At this point, maybe. Oh, okay.
I wanted to move on to the next point, so go ahead if you want to add something to that.
Yeah. So you wrote in Azure there are some virtual machine types that don't support the resize at all for pods running there, right?
Mm-hmm.
So
yeah,
if this fails, then it will probably just fail, right? So the PVCA might attempt to scale up. This will just fail, and the PVC would be then in the I don't know, strange state at least. This goes into the same question: what do we do then?
Yes. So the only thing, this is why I wanted to add this these strategies so that the operator kind of instructs the PVC that the scale up should finish automatically with this eviction of pods. So my idea is to wait some time after detecting such an error. And if scale up doesn't happen, then we could try evicting the pod. This is sadly not sadly, but yeah, this is the only way that you could finish it on such VMs. And thank God. So at least in VM types that we use in Gartner, they are not affected. So for our seeds, so it's mostly a problem for stakeholders eventually once we offer PVC autoscaler to them. But yeah, by then, as I said, the option that we've tried that could fix this is to detect how long PVCs have been stuck in such time in such an error, and then automatically evict the corresponding pods for these PVCs. This is why I wanted, so this is why in the status in the API, when we provide information for PVCs, we would also include which pods are actually currently mounting this PVC. I mean, this might be useful, but yeah.
But the strategy is also some field in this PVC API, right? So again,
you mean, yeah,
somebody has to set it.
Yeah, what I mentioned is that, yeah, you're right. And then it would potentially also have to be exposed here, if that's what you mean.
No, I think it's not about here. It's about the API above.
Yeah. What Rafael means is that it has to be set, but yeah, again, this is something that would be necessary for
There's some provider-specific value then that must somehow be set. Currently, the proposal is the seed setting, but we also discussed the webhook approach. I guess we can revisit this at the end. Okay. And
again, this is this is something that, as I mentioned, we want to do later on. It's not something that's necessary for seeds and the runtime clusters. Again, it's something that's right now necessary only in the future when we offer this to stakeholders. So we have time to go ahead. Sorry.
I want to discuss the source of the usage metrics, basically. So for HPA and VPA, the metrics API of Kubernetes itself is used, which provides the container, CPU, and memory usage, right? So I'm wondering whether there's some ongoing work upstream for like providing the PV usage as well via a similar API. Instead of going through some metric storage system.
So you mean directly from the API server?
Yeah, probably it would be an extension API server, just like the metric server. It could even be in the metric server itself, which already connects to kubelets for fetching CPU and memory usage. It could, in theory, at least be extended to also fetch the usage metrics for the volumes from kubelet and then expose it via some standardized API, just like the kubectl top pod and so on.
Yeah, to be honest, I think I noticed some requests for people to do this or for such future development, but as far as I'm aware, at least since writing this document, I don't think there's anyone doing anything in that direction right now. I agree it would be beneficial. I was thinking whether we actually would want to later on implement our own metric server that might fetch these metrics. Again, it's probably better if we could convince Kubernetes folks that to include this in their metric server. But yeah, currently this is the only way. So you could either get it from Prometheus, which scrapes the metrics. You either have to have certificates of the kubelets and scrape the metrics endpoint of them individually, or you could do it with a proxy through the API server right now. But from all of those, as you say, a separate metric server is a better approach. But yeah, this is again something that's not yet in development, and metrics actually are still even alpha version. The PVC metrics, so that might also be a reason that nobody has started doing anything in that direction yet.
Probably a follow-up question to that, because I'm thinking about the dependency of on Prometheus that we are introducing here.
Yep.
And the Prometheus, whichever one it is now, will also have some storage, right? Should we autoscale that as well, or is that a specific non-goal?
Yep, the idea is to also scale that, but have it with a larger capacity. And this could also, I mean, this should be enough for, I mean, there should be a consideration here for AWS, whether we could reuse, again, these settings either in the seed or via this webhook to be of a particular larger size than other Prometheuses on the AWS seed. But again, for now, the goal is to also scale it, but just have it with a larger initial size or larger step increase than other Prometheuses.
So, and as our Prometheus is, I would argue, considered not necessarily HA, we assume that, or we are fine with either the Prometheus being temporarily not being available, for example, because it's rescheduled to another node, and then PVC autoscaler in that time frame has no new data and will probably not react to changes accordingly. So the assumption is that this is fine because we build in buffers that we not scale at 99%, but at, like you said, 80% or whatever. So we waste a little bit, but assume that eventually also our metrics will be available, right?
Yep, that is my assumption.
One minor thing,
Another
maybe, since we
larger
talked about
question.
Go ahead, Tim. This time you first.
Another larger question for me is why etcd volumes are out of scope. You didn't mention it in the document, so I assume it's out of scope, but I'm wondering about the reason, and probably it should be explained in the document.
Yep. Sorry for missing this. So yeah, they are out of scope because they kind of want to manage PVCs themselves when they scale up or when they scale down. And they are just currently working on being able to properly rescale their or resize their PVCs from the etcd resource. So they expect that you would change the etcd, the size in the etcd resource, and then they can roll out changes to the PVCs depending on which etcd is currently the leader and which one isn't. And they also want to include downscaling in that case as well.
So,
But yeah,
sorry, I didn't get that. So is this like a technical limitation, or are we just talking about different people working on it? So there is another technical solution.
I think we're talking about different people working on it. Yeah, because right now I mean, I had a few things with them on whether they plan to use it or not, and we decided to postpone this for later. So yeah, for now, etcd is out of scope, just observability components. After we have it running for observability components, we might talk with etcd folks again to see where they stand with their idea on how they want to scale their own PVCs and whether they want to also use PVC autoscaler or not. But yeah, currently I would say since it's different people working on different topics, we have not agreed on using PVC also for etcd.
And
Yeah,
maybe
I might be have the wrong, might be remembering incorrectly, but I think from the previous iteration of the PVC autoscaler discussion a little over a year ago, I think it was in the direction that we start with observability components, because also we think the observability components are not as critical as etcd. And then we gather experience, and once we have experience, then we can still think about doing etcd, but I think, as Plamen mentioned, I think the etcd folks meanwhile also have made up some plans, so we need to align then probably again. But I think gathering experience
that's a valid
anyway
approach.
Yeah.
That's a valid approach, but at the end, the etcd volumes are probably even more interesting, right? Because we tend to have 6 per HA control plane, probably all of them using high performance class, depending on the infrastructure. So even if you enable the observability components in your landscapes, I would expect that the etcd volumes contribute the highest cost to the overall volume cost in seats.
I think with etcd, there are multiple problems why such a simple PVC autoscaler probably won't work. They also need to reconfigure etcd itself. So there are some things that go beyond just the disk. The what is it called, quota backend bytes. Normally you configure it, the default is 2 gig. We have configured it to 8 gig. So if you increase the disk but don't increase the etcd configuration, then you have a problem. They also wanted since a very long time to implement it anyway. If volumes need to be migrated for hibernation, true hibernation, they want to get rid of the volume. So I think, as you said, Plamen, and you asked him, it's different people and a different implementation. I don't know how much reuse can be possible. Probably yes, but because you also said they will need to support downscaling, they have also the data somewhere else. They can basically add another learner, promote it later. So they have other means, other capabilities. So this is also a reason why they are doing it this way or plan to do it. So it's a long outstanding topic, which is also an interesting point. So sometimes just increasing the disk might not work, but maybe for most of the workload, for our observability stack, it will work. I would have another question in another direction, and that is, you have not really said it, but it's a non-goal. Should clusters are non-goal, right?
You mean for stakeholders right now, or?
Yeah, exactly, because there's something really cool, but then starts the problem where you're getting your data from. I haven't really found the configuration in the document. Maybe I read too fast, but somewhere you must configure, or a hard code, or I don't know, your Prometheus endpoint. So this is all very specific, and in a shoot cluster it may look completely different, but it is a very cool feature.
But just to understand, I understand it is a goal. It's not the goal for the first phase. I think there was kind of multiple steps at some point, and not the point to scale down, but at some point it was a goal also to deliver to stakeholders.
Yeah,
so maybe we should clarify.
Yes, sir. We do plan to also offer this to stakeholders, but as I said, this will happen much later on. So after we have done it for observability components, and for then we plan to either discuss it again in some round. Maybe we see if we have to open a gap or not, to change how we actually, well, not change, but to enhance how we are able to get metrics. And maybe by then we see if this, what Tim also mentioned about the metrics server or some metrics API that could be used to fetch PVC data directly from the API server. Maybe that gets some traction. But again, this is why it's something that we did not want to discuss for now, just to remain on focus for our own components.
In the doc, I'll probably mention it, right? Because in the doc, it's not clear that.
Okay.
I actually, now that you said it, there is phase 3, and probably this was the sentence, may require different metrics access pattern. So this is
this is exactly
get the data. Okay.
Yeah, this is exactly it.
Thanks.
We only have 10 minutes left, which we usually reserve for decisions. What is your? Are there any questions left? What is your general?
Yeah, quite a few actually, to be honest.
So should we schedule another session, since we will probably not have enough time today?
Yeah, probably we should schedule another session, and maybe this is also a learning for the process itself, not particular related to this proposal. I suggest, like in the GEP process, open the PR, including the proposal, allowing for feedback up front and clarifying questions, like we did it for GEP 32. Or was it 36? I don't remember. 36. And then we should be faster or more efficient in this particular steering meeting. So I have quite a few technical detail questions, which probably won't influence the decision, but it would be helpful to clarify them upfront. I suggest at least clarifying them asynchronously, but doing it on GitHub would help for transparency and catching up.
But just to understand, you said that won't influence the decision, then we can take a decision. But if it will influence the decision,
we can take a decision now, but still, I would like to clarify the details.
Yeah. Okay. So I think maybe I would propose maybe we schedule another slot then, and do it there. First, clarify the remaining questions, because maybe something comes up, and then we want to decide to change something or whatever. So doing a decision now while more feedback and questions come later is a bit strange, I would say.
Yep.
So we can use the remaining 6 to 7 minutes for more questions. I will schedule another slot, and then we can just continue from there.
The thing that I
good.
would like to say, even if you don't take a decision, the problem is there, it's real. Since we target, at least in phase one, something more like only the seed cluster, I'm actually also very okay to just dip the feet into the whole problem and trying to find out how to do it, what kind of problems we will find, because right now we have already problems. So we have already the case that either we oversize or undersize them, we cannot really upscale them. So it's not like with some other decisions where we can decide to not do something and then we don't have.
But this is also, I think, clear already, since this is a technical steering, not a product steering. It's clear that we will work on it. Here we want to decide on the technical details, APIs, and
which is fine.
whatnot.
Yeah. Then we should have the follow-up questions. Yeah.
Okay, then 5 more minutes. Who wants to shout out another question?
One detail you mentioned in the doc is that owner references are looked up for checking if a pod belongs to a component like the target controller. But as this proposal doesn't include a admission component for pod creation, I'm not sure where this is used. Can you explain that?
Yeah. So yeah, the main way that we would find it is that we use this chaos resource, as I mentioned. The owner references could only be used to check if the of a particular targeted. So it could be used for verification, right? To ensure that only one PVCA is targeting a particular deployment. So our concern is similar to what it was in VPA, where you could have, for instance, one. Now this is a dumb example, but it exists. So you could have one VPA that targets a deployment, and then one VPA that targets its replica set, for instance. And you can use owner reference to ensure that you're always targeting the topmost controller. And I think the what you mentioned about finding pods from owner references, this was, I think maybe I missed to remove it, but this was older idea for the API. So we now only want to rely on the scale subresource. And you're right, owner reference would only be needed if we at some point want to add an admission plugin. Yeah, again, similar to why they are used in VPA.
But why would you need the scale subresource? I also didn't get that. So why you don't just list pods?
I mean, it's faster with the scale subresource. You could just get the selector for which you want to list the pods. So you get the selector from the target ref, and then you list the pods. And you might be wondering then why is this a target reference here instead of, for instance, label selectors or whatnot. But this kind of also allows you to, I mean, it's easier for operators to see which workload is targeted by this PVC autoscaler. And for which workloads PVCAs have to be selected. And it's also a bit easier to validate that a particular PVC is only scaled by one PVCA, if you
I still didn't get it. So what is, again, the benefit of the scale subresource? So here we are targeting the seed Prometheus. So how do we now find the pods belonging to this?
You get from the scale subresource, you can get the selector which Prometheus uses to select the pods, actually. And then you can use this label selector to select the pods from which you select the PVCs.
Okay.
And I mean, for instance, VPA has some improvements, for instance, for deployments or other what they call well-known controllers, where they just, if it's a well-known controller, then they know where this selector for pods is. So it's in the deployment spec or replica set spec or so on. And they can just fetch it from there and use it to select all the pods that are owned by the controller.
Maybe
but
can
HPA, for instance, does not have this.
Can I have a quick question about the process in general? What kind of detail level makes sense to present on this kind of technical steering committee and on the GEP? Because from my understanding, the GEP is where you highlight all the details. So can you give a general guideline what kind of detail level makes sense to present at TSC?
Is there a GEP available for this topic?
Currently not, but in general, for future.
Okay, will you open a GEP for this proposal, or is it replacing?
There was a GEP for this proposal some time ago, but it was not not merged, and it was different.
Yeah. My question is process-wise, not this specific one, future ones.
Come again, what was the question? I mean, there doesn't need to be a GEP. There doesn't need to be a GEP. So, I mean, we're discussing a technical topic in the Gardener ecosystem. And it doesn't necessarily need to be an enhancement proposal of the Gardener core.
Okay, so what kind of detail level is required? That was my main question. Like, because there may be a lot of niche details that make or make not sense to be presented.
I think there is no easy answer. The right detail level. So, I mean, of course, I think we have people in this call, also in the technical steering committee, who like to dive deep. So therefore, some discussions will end up quite on a detailed level. But the proposal doesn't necessarily have to go into all the nitty-gritty details, because then it's probably, you can end up with huge documents, right? So you have to find some balance in between. And that's not a clear guidance, I know.
Because for me, for those details, you kind of have to start having some POC or to get hands-on the problem, right? So, okay, I think I got the answer.
Yes.
I mean, process-wise, usually when you start complete new topic, you would usually first do a product steering to discuss whether it makes sense to even get started with a topic. Then you would do some POC, hands-on research, implementation proposal and whatnot, and this is then discussed in the technical steering. And here details should be crucial part of it, right? So like the APIs and everything. So for me, this level here in this document was good. So I liked it a lot.
Okay.
Yeah. Okay, time is up. Then I have written to the chat, I've made 4 proposals for continuing tomorrow or on Thursday. Please vote. Then I will set up another slot so that we can finish the topic. Thanks for joining and see you soon. Bye-bye.
Thank you all and bye-bye.
Thank you. Bye.
Thank you. Bye.
Okay, cool. So here we are again. Back to the technical steering for autoscaling persistent volume claims. And without further introduction, I would say we directly dive into the next set of questions and feedback.
Meanwhile, let me just share my screen again with the document. Okay.
Okay, anybody?
Maybe we can start with a general question. So are volumes only scaled individually, or is the usage of similar volumes or peer volumes, however you might call them, also consulted? So imagining we would have etcd volumes in scope for now, probably all volumes of a particular etcd cluster have a similar usage pattern, so we could potentially accommodate for this in the calculation. Is that something that we consider useful?
So far, I think not, because it's very different depending on the application that you look at. So, for instance, at least some Prometheus instances that we checked, which are HA configured, didn't have 2 similar patterns. So we decided to stick with separate scaling, so per persistent volume claim. This is one of the reasons that we also want to have this information in the status of the resource. So separate each persistent volume claim resource there in this array here that I showed yesterday, and then recommendation decisions are actually taken. Not recommendation, but scaling decisions are then taken based on this. And this is, there were, maybe I could also say here that there were discussions at the start whether we want to actually separate this in multiple resources. So we have this as a general resource that says the settings, and then each persistent volume claim is handled by its own CRD, but we thought this might be, at least initially, a bit more complex for operators and to track status. So for now, we decided to stick with this, and we will see in the future if we have to do this separation maybe.
Okay, got it. Completely different topic, but I was wondering whether we need an admission component that mutates the PVC specs on creation, or updates probably, because there might be some controller trying to update PVCs, and then it would result in invalid specs because it would decrease the size and so on. But if I remember correctly, you also said that the stateful set controller only creates the volumes, and this is probably the primary controller for the PVCs that we target for now. So we don't need an admission component for now. Is that correct?
Yes, this is correct. So we also checked because there is this CAP that Kubernetes folks are currently working on. So it will make it possible to edit persistent volume claims persistent volume claim templates inside the stateful set. But again, it will only allow increasing the size. And they have also factored in the fact that people, or at least a lot of people in the community, now have their own solutions to scale PVCs, and everybody kind of relies on the fact that if they want to upscale their stateful set PVCs or even other controller PVCs, they generally edit the PVC directly. And so controller authors usually have this case covered. So they check if the PVC is higher than what is specified in the controller spec, then they don't touch it. However, if it is lower, then they would increase it to what is set in the spec. But we rely on the fact that whatever is set in the spec, this is what the PVC is created. And if it's lower, then it would be due to downscaling, which is, again, one more reason that we do not want to support it for now. But yes, if we, in the future, if we do add downscaling, we would probably need an admission. It's a bit tricky though, because when the admission checks the PVC, so you have to somehow remember the mapping between the PVC and the pot that it is used, or the PVC and the controller that determines how much the size of the PVC is. You have to remember it in the status here as we did, because you can't build the same chain of owner references that is used for pots in VPA, for instance, because for PVCs there is no owner reference to the owning pot or the owning controller, and there is usually also no labels, or at least we can't rely on them because it's not, let's say, similar to service where you have this ingrained in the API design, where the label selectors in the service are also part of, or are also used as labels on the pods. So you are ensured, for instance, that by selecting that the service selects particular pods. What I mean to say is that you can't be sure that by having some selectors in a deployment or whatever, they would also match the labels on the PVCs. I mean, some people add them, but not everybody, because PVC, the only mapping that's enforced by the API is this volume claim source that is inside or volume source that is inside the pods.
Okay, but downscaling is anyway out of scope, right?
So, yes.
If I remember correctly, when we met in December, you mentioned something that there is some dependency on the CSI for downscaling. So it's not even supported upstream, right? Can you remind me again what was there?
So it's not really a dependency. It's more like it's not available. So resizing is only available for upscaling in the CSI controllers. And downscaling is not implemented at all. So the only way you could do it, as I mentioned yesterday, is with rsync. And even provider-specific solutions, they don't exist, or they also have documentation on how you can use rsync with creating a new persistent volume, and then reusing this persistent volume in the stateful set after you delete the old ones.
Okay, but it's all probably something that we would not do on our own for now. So we would probably want to rely on any upstream guidance, at least. How this should be done in Kubernetes. Okay. Maybe this could also be clarified again in the document. I think this was not too clear why it's out of scope, simply because it's not supported upstream, right? Okay, and another maybe small thing that I have written down in the document, you said about these metrics that are used for the scaling from Prometheus, that they are alpha and they might change, and that there will be tests in the Autoscaler repo when a new Kubernetes version is added and to detect this. I think these tests should rather be in Gardener, right? Because there we add these new Kubernetes versions. So if we do it in the PVC, we would detect it too late.
Yeah, I thought about this. Even before I raised this as a question, the monitoring folks, they opened these Prometheus health checks PR. And they have now also added these metrics to the health checks. So if when we run tests, these are now also part of Gartner, or they are part of tests in Gartner as well. So we would get a problem or the Prometheus cache inside our seed clusters when it's run in tests, so end-to-end or any others. They would not be healthy if these metrics are missing. At least on that side, that is covered.
Okay, and maybe this can be mentioned then also there.
Yep, good point. It was just added after I already wrote the document, so I think it was like maybe 1 or 2 weeks ago. So I will add it now.
Yeah.
Regarding the support for different Kubernetes versions that might change the metrics, I was wondering whether it would make sense to make the metrics query configurable right away, because it could help like deploying the PVC autoscaler for different Kubernetes versions with appropriate metrics query configuration, right?
Yep, that is already done. It's part of the actually already existing PVC autoscaler.
Okay, cool, perfect. I have a few questions about the API design, mainly specific fields that were not explained in the document. At least I didn't see it. So I was wondering, for example, about the stabilization window duration, what it means exactly.
Yes, I think we also added this. It's my bad here that I should have added this for if we do add downscaling. So the idea here is that you do not, yes, it's similar to HPA again. The idea is that you could potentially upscale, and then you could have a threshold percentage that is, so for instance, in the threshold percentage is the scale down setting that is also passed. So this could cause an immediate scale down, if you get what I mean. And the stabilization window is kind of something used for that, so that after a quick scale up, if there are some files deleted or not, if there are some files added or not after scale down, so that you don't do the opposite operation basically at the same time. I mean, it kind of covers itself with cooldown duration, right? Depending on how we also implement that. But again, it's something that's part of scale down, so yeah, something for the future.
Okay, got it. Another question is the strategy. I think I get in place and off, pretty self-explanatory. Can you quickly sketch how evict pods, if necessary, would work?
Yeah, it was actually a very good.
For example, also why you would want to choose that over in place.
Yeah, this was actually a good question, also raised by Rafael yesterday. So I was thinking a bit about it. This was because of this case where you would have some VMs, for instance, on Azure. But yeah, again, we're not sure if there are also some such VM types on other cloud providers, where the volume has to be detached or the pod has to be evicted for some time for the resize to actually finish. This is mostly on older machines. And again, it depends on the type and the implementation of the CSI resizer. So this thing here would be added by operators if they are okay with this short downtime of evicting the pod. So if they don't have an HA setup, so that the PVC can be resized. And if they have an HA setup, then I guess this would be the default. And I was actually wondering whether we should even, maybe even remove it and include it as default behavior in place. Although I'm not too sure, because I would like operator. I mean, when I was designing this, I thought that it should be a conscious decision on the operators to state if they are okay for pods to be evicted when they want PVC to be resized. But yeah, I'm a bit. Still evaluating it right now. This is why this is also part of the phase 2, or after we add this in Gartner.
without having much experience, I would expect that in place is the default value that we want.
Yeah, exactly.
Also, because if I get the whole CSI resizing approach correctly, it is thought to be in place most of the time. I mean, obviously there are some constraints on some providers, but in place is probably what we want by default if we enable it.
Yeah, I think also maybe it's a bit confusing when it's stated like this, with this evict pot if necessary as a separate, because I mean it would still be in place, so the PVC would be edited directly. The idea is that to finish basically the resize, you need to restart the pots.
So the volume already has a bigger size, but the mount or something needs resizing. So some node level operation needs to happen.
Yeah, some node level. Yes, exactly. And kubelet can't actually detect that the volume has already been resized without the pot being restarted, or without the volume basically being remounted. I guess this is also one of the cases.
But the resize actually happened or doesn't happen? So is it just that kubelet doesn't see the new value, which is missed or bad observability? But if the resize actually happened, then it's okay. We see wrong information, but everything works as planned.
I think it's so kind of the file system itself hasn't been resized at this point, because the file system in those machines, the file system cannot be resized without the volume being mounted. So yeah, Kubernetes, the CSI resizer has seen that the capacity has been increased. It probably has increased the block storage underneath, but the file system itself is still the old smaller size. So basically the file system is what the pod would see where the volume is mounted. But again, to be honest, this is also very like CSI resizer specific stuff also, and kubelet and volume. So I'm not too much aware on what exactly happens internally.
Okay, but what do we do with this thing then? We keep it there because it's needed on some providers and must be set to evict or restart or whatever, right? So you said it's even for only some machine types on Azure, for example, not all machines, so not Azure in general.
Yes, exactly. It's only on some machine types.
But that means that basically the operator, I mean, I understand that you want to have it explicit, so that it's not implicitly deleting pods, and you don't, if you don't know it, but that also means the operator actually needs to know that you're running on an infrastructure that has this site conditions and might need that, and you have the type, so it complicates the API a bit. So I don't know. Yeah. But I understand that it is a different scenario, and that you might want to have that explicitly.
Yeah, I was thinking exactly in that direction actually yesterday evening as well, but still.
But I think we
50-50.
discussed this yesterday, so if I understood correctly, the implementation is, so on Azure, let's say we set it to recreate because we know on Azure it might happen. And then the controller, so the PVC controller, checks or just waits if this finishes with some whatever timeout. And if it doesn't finish, then it tries to restart the pod.
Yeah, that was.
It might also not finish because of other reasons. Maybe something went wrong, but maybe it just needs a restart. But this cannot be reliably detected, right?
Yeah, it's so it will stay. Usually, if there's an error that the resize cannot happen, it's added to the PVC conditions. And in this case, the condition just stays with something like waiting for a pod to be evicted. So the problem is that or waiting for the pod to be restarted to finish resize. So the
This is
problem
coming
with
from the CSI, or
no, this is now coming from the kubelet. The problem is this is so it's kind of an old implementation back from the entry providers where automatic resize was not possible. So everybody had to restart their pods to finish resizing. And the kubelet, so this logic was still kept in the kubelet. So even if you now have auto resize, this condition will be present, but it will be removed rather quickly when the CSI resizer supports auto resize. So, and if the PVC can be resized on the particular VMs. However, if it can't, then the condition remains for a longer time. So we could rely on it, at least that's my expectation. But yeah.
Okay, so if the condition stays for too long, whatever this is, we try to restart if this is configured in this strategy.
Yep.
If not, okay.
Yeah, I was also, by the way, here I was also thinking, but again, this is for later, the strategy.
Do we need the strategy then? So, I mean, if there is such a condition and it's too long in the list, then we could just always do it, right? Because it seems that it's needed. What is the benefit of the strategy then in the first place?
I think so I would still keep it for off or in place. So to be able to turn off autoscaling for particular PVCs if we need to, just in case. Again, similar to VPA. And I would also keep it in case somebody wants to use this controller just for the provided recommendations, so that we can separate the algorithm that does the recommendations. And then if somebody wants to scale it themselves, so for instance, if they write some middleware controller, they could just check the recommendations in the status and then apply the scaling themselves. And I was actually thinking something like this for etcd Druid. So if we write again some middleware controller, or if they agree to add some implementation in etcd, then we just provide them the recommendations, they fetch them, and they then know how to patch the etcd size and so on.
Yes, this is fine. But then what about this evict or restart field? Then we can just
you mean
remove that.
Yeah, we could. I'm okay to edit it. As I said, after thinking a bit more about it yesterday, after you asked, then I'm okay to also remove it, to not edit in the future. I mean, not edit, but yeah, just have it by default.
Yes, if the condition of the kubelet stays for too long, we just restart after some time.
Sounds good.
Okay. Maybe also a minor thing that I was not finding in the document. So you talked about the runtime cluster and garden operator and so on, but this is not mentioned at all, if I am not mistaken. So the plan was to also deploy it in the runtime cluster via garden operator.
Yeah, the idea is that for the runtime cluster, I think it's not too critical, right? Because it's just one cluster, we can usually manage observability a bit better there. I mean, again, there are issues because we collect actually a lot of things from control planes, at least for Prometheus, also from shoot control planes, seed control planes, and so on. But I would also potentially first do just the addition for the seed clusters. And then in like a separate phase or a separate PR, do also the addition for the garden cluster.
And also, I don't think that there is much value, because the main value for shoot clusters is cost optimization and utilization. So for the garden clusters and solving the problem for missing metrics, observability signals, right? So for the runtime and garden cluster, we can just manually provision a large enough volume.
Manually, okay. Why would we do that manually? I mean, Usually we automate everything. Nobody wants to manually scale something up there. We already have the component.
Yeah, it's possible. I mean, but
the main point is just that we have multiple shoot clusters, shoot observability instances. So there, the scale makes it more interesting to use. So therefore, I see the seed also as the more important part. But I think, or my understanding was also that we put it to the operator as well, because there we also want scaling. I mean, for new landscapes especially, we want to scale up to the point where we actually use it. For existing landscapes, okay, there we would maybe need to scale down, which is not so nice, but yeah.
So what is the plan now? I'm now a bit confused. Do you want to add it to the runtime cluster, or do you say it's not valuable?
Yeah, we can add it, but just the concrete story about this was for the seeds observability volumes. We can, of course, add it.
Okay, yeah.
Yeah, we just wanted to focus on the seed to not like
it's obvious that for the seed it has more benefits, but it also has benefits for the garden cluster, right? There we also have some logs, and this can similarly fill up, and then retention would be too low. So it's obvious to me that we want to have it there, even if it's just a single cluster. Yeah. Okay, then let's also mention this in the doc.
I will also add this in the doc, yes.
I have another point. Nothing new. We already discussed this yesterday, but I don't think we actually reach a conclusion whether we want to mutate the PVCA objects in the provider extensions to match like rate limits on AWS and other constraints that the infrastructure might have, or do we want to expand the seed API with like every possible setting of the PVCA object?
So yeah, first a few things. So the settings here in the seed allow us to basically configure settings on PVCA when it is deployed. So sort of like start PVCA by saying this is the minimum absolute gigabytes that you can scale any PVCA autoscaler with, so that you don't have to, for instance, change the PVCA themselves. But you are right that it would also work by mutating the PVCAs directly. So for VPA, we have these max allowed stuff exposed in the seeds, but there it's mostly because the VPA API is very limited. So it doesn't actually allow for too much configuration related to settings like this. But yeah, for the PVCA, we could definitely do it with a webhook. To be honest, I think the only thing that I do not like too much with that regards is what we said yesterday, that if we change, for instance, the API for whatever reason of PVCA, then all these webhooks also have to be adapted, right, in the separate provider extensions. I mean, and on the other hand, though, it would also be a simpler way to solve the fact that if a provider extension decides to deploy also a PVCA, and for instance, if this PVCA deployment is somewhere in the generic actuator and the provider extension doesn't have any control on it. If you get what I mean. I mean, this is highly...
I didn't get the last point.
Yeah, it's highly theoretical, because I was thinking that, I mean, a couple of days ago, I was thinking that when we add these settings to the seed, then let's say a provider extension wants to deploy also its own persistent volumes or not its own stateful sets and so on, then it would kind of have to know what is configured in the seed, or the settings should match in some way. So for a provider extension, for a provider extension...
So just another point for using the webhook approach, right? Okay,
yes.
Yeah, I'm strongly in favor of that one, because it will also be simpler for newcomers to the Gardener, and yeah, just using the AWS extension doesn't require any additional seed settings to accommodate for the rate limits. So I see the value in having this enabled field per seed, also for gradual rollout. I think that's fair enough, and it's also similar to what we already have in the seed settings. But I wouldn't like to see any field in the VPCA object being exposed here in Seed API to accommodate for provider specifics. That should rather be in the provider extension.
Maybe one thing that we could keep here is still this max capacity thing, to just have global settings if we need for our seed clusters. If operators want to, for some reason, limit the max capacity on a particular seeds, because this might not be dependent on the provider. So this might be what an operator wants to spend for volume cost, for instance, on this particular seed. This is, again, this might be a setting that's actually present here. But yeah, for the cooldown duration and absolute and minimum step, which are provider specific, those are probably better to be in the AWS or in provider extensions.
If we scale multiple different kinds of PVCs in the future, operators might want to select that they don't want to spend too much on, let's say, the logging stack, but ensure metrics are kept for way longer. Just a random example. So having just one max allowed field is probably not enough then, right? So
that's true.
I'm rather thinking in the direction that if operators want to have such specific limits, it might make sense to just use some policy engine like Kyverno on the seeds. Yeah. But again, this then requires additional components, which not everybody has. So yeah, I'm a bit torn between keeping the API and the seed simple and not having new fields every month, versus giving the flexibility that most operators need.
Yeah. We had the same problem with VPA for instance, for limiting it for etcd, Cube API server, and so on. I mean, we can always. So what I would vote is to, I guess you're right. Maybe we don't have to expose this initially, maybe not all. So we could start with the simplest possible API, which is this persistent volume claim autoscaler, whether it's enabled or not. Leave this for a webhook or whatever. And then if only very, very, very necessary, if we can't figure any other way out to, or if we actually do need to limit capacity, because again, this is some theoretical thing that we are discussing right now. If we do limit capacity, then we can come back to this, right? I mean, come back to this discussion.
Yeah. Sounds good. And then maybe because you are then on it anyways, this volume minimum size field that you also mentioned yesterday in the Seed API, this was also introduced long ago. I don't know, first days of Gardener, because of Ali Cloud, I think mainly, because there is the limitation that you need at least 20 gigabytes or something. And I think that's the only provider where this is needed. So maybe when you write these webhooks anyways, you could also just move this there into the webhook, and then we can get rid of this field as well.
Yep, exactly. I was also going to suggest the same thing. And I mean, just want to mention one thing here, because I looked at it exactly for this reason yesterday. There we modify directly the storage on the upstream controller. So we, for instance, start Prometheus with, or we set the size on the Prometheus object to a larger size. But I guess it's no problem to just mutate the PVC directly for this, now that we know that Prometheus won't complain if the size in its spec is less than the size of the PVC that are created for it. Well, why I say this is because otherwise we would need to mutate Prometheus, and then this means that we have to know that Prometheus is deployed by GardnerNet or Valley is deployed, which is not.
Okay, I only have one thing left on my list, which is about the alternatives. I looked a bit at them. You listed 3, I think. And from them, only the first one looked pretty much close to what also you want to achieve. And I think it's also more or less actively maintained. At least it had a release in the last days, while the others had their last release in 2023. So I was wondering why this is not suitable for our case, or what they do so much different than we, that we cannot use it, or at least shape it to our needs.
So at least when I looked at it, last year, I think it wasn't too much maintained. So maybe they started working a bit more on it. Right now, it didn't have too much error correction states. Didn't track too well which PVCs, not which PVCs, but the whole scale-up process of the PVC. It was using these annotations approach, where you had to annotate the PVC with the threshold size and whatnot. Maybe they changed it afterwards, but yeah, back when I was looking at it, this was the case. And as far as I remember, it doesn't support inodes scaling as well. So yeah, because back then, I mean, it wasn't supported too much. We decided to roll with our own, right? And also mainly because of the lack of the CRD.
Yeah, okay. I guess it's kind of to be expected in all cases that a project doesn't immediately fulfill all the needs that you have. But the question is if we really want to do this on our own, or if this makes sense to shape this a bit so that we can also use it. Because it also uses Prometheus as an API. I think it also can do it via the metrics API.
Yeah, it's very similar. I mean, I don't know. It might be hard in this case to also push our requests for this. I mean, or to convince the authors that they should, support what we need, potentially support what we need in the future. It's a bit easier to do it when it's our own project. And to be honest, the code, so the controller isn't too complex for us to maintain. But I would agree if it was some operator that manages more resources, that has a bit more complexity in its code base to be reused. But for something as simple as this, to be honest, I don't have. I feel like it's better if we own it and we maintain it and we adapt it to our requirements.
Basically asking the question from Raphael from a different perspective. What do you expect if we ignore the downscaling, which obviously seems to be a bigger endeavor? Do you think that basically once we implement it, then it will just stay as is, or would it need a lot of maintenance because CSI does stuff differently and will change in versions and so on? Or is it basically, do you envision this as a stable component and it will just work, and we will have to update the Go version every now and then?
Well, so the only thing that I'm mostly worried about is the alpha metrics. Resizing hasn't changed too much in the past couple of years. I think the new thing is this revert thing that they are doing. And then I guess my expectation would be that it's a stable component that would not require too many changes. The thing that we do. I mean, too many changes related to third-party software. We might have some changes related to, let's say, add a new feature, a new field in the API for something or whatnot, but I cannot think right now of any particulars or concrete examples.
I'm also taking a look now at the component. I mean, it is iNotes they added, but it's really an annotation-based API.
Nice.
So that will be might be a little bit difficult to convince them to change the API. And I like actually your proposal a lot more because I know VPA, it is very similar to that. And the annotations look pretty ugly.
Yeah, of course. I mean, we also started, if you remember, in the first version of the PVCA with the annotations approach, and then went to the CRD one. But yeah, I was just looking a bit into it, and from what I read in the doc, so our doc, the things here looked pretty much like what we want to achieve. Also with the metrics and the source of the signals and so on. But yeah. I mean, in the end, I know that. Sorry.
What the colleagues have proposed on our end is, so for example, stabilization window, cooldown, these are also metrics configuration settings that we know from VPA. They are also missing here. So you need to convince them to implement a completely different API. And I mean, the rest is maybe tiny things like cooldown and stabilization window, but they are also algorithmically not where we basically know VPA and what we want to achieve with the PV autoscaler. So yeah, I understand, of course, joining a community project could be good. But I'm not so sure how close they are.
Yeah, to be honest, again, when I looked at this last year, well, maybe when we started writing the document, which was even before that, development didn't seem so active. So I was actually surprised that they had also looked at this CAP for the stateful set controller, which allowed modifying volume claim templates. I guess this was maybe one of the latest developments. I'm not sure if this is why they made a release or but not. But
they have a release every month.
Oh, really?
So it's very active. But yeah, I understand. I also don't want to bring up this question in every meeting again. I understand that it's of course more attractive to write this on your own than joining them. But yeah. Okay, let's just skip this then. Okay, any things left? We have 15 minutes more or less.
I don't have any questions left. Just some feedback and my view on how we should move forward.
Sure.
Should I go for it, or are there any questions before that?
No questions from my side.
Okay, cool. So obviously I would ask you to incorporate the points that we have had in the discussion. And I would also like to ask you to remove all the points related to scale down, as we saw, like the stabilization window caused confusion. And I think it's fair to say that this is a non-goal, right? For now. And once we want to tackle scale down, we can have another document and give feedback based on it. I think that makes it more focused and clearer and so on. Same goes probably for the other phases that we consider optional for now, like offering this tool for shoot owners. I think there would be quite a few challenges, as you already teased in the document. If we want to work on it, we should have a document that addresses these challenges, and then we can take a look on it separately. But for now, it would just be fair to state it as a non-goal and just omit everything from the document, right? Because saying we can do it in the future, but we don't know particularly how, and we need to look into it, doesn't add any value to the design document for now, because that's not what we want to focus on now. So this is probably also a good point for adding like the goals and non-goals section that we also have in GEPs. I know it's not part of the template in this repository, so that's probably why you didn't include it. But we should probably also add it to the template then, so it makes it easier. And this also includes specifying that etcd is out of scope for now, because we want to get some experience with the observability stack first. That's totally fair to state it like this, or even that other people are considering this. And that makes the proposal more focused on what you're trying to achieve in the first step.
Yep, I
Apart
was
from that,
exactly.
Sorry. Yeah.
Sorry, I was exactly going to mention that, and so was about to ask you whether we could incorporate it in the template with goals and non-goals, because it was also a bit hard for me to come up with the intro section.
Yeah, we probably should move to a more centralized approach with a harmonized template for gaps and steering proposal. But yeah, we should evolve the process as we go along. You're right. Apart from that, I would like to ask one more time to consider even opening a Kubernetes proposal for the PV usage metrics in the metrics API or metrics server. I think that's really valuable to a lot of Kubernetes users, independent of autoscaling or not, and would be a great opportunity from my perspective to go into the community. And probably it would also be like a more stable implementation and obviously simpler implementation of an autoscaler than requiring Prometheus as a dependency. I wouldn't say we strictly need it, but it's a great opportunity to collaborate here with the community, and yeah, would be valuable in general. Yeah, that's probably my feedback, but I don't have any strong objections or anything. So from my side, this is a clear go, because I see the value of the proposal. I think the general approach is sound, and yeah, we should implement it.
Thanks for the feedback.
Just providing also the feedback from my side. I think in general, I found that, as Tim already mentioned, I find the use case is very, very obvious. It's clear that it provides benefit. I found also the document very good. I think in contrast to Tim, I find it good to also see a little bit, not just focus on one single thing, and then also a little bit the vision where we want to go. I agree basically with the downscaling. That's kind of as it's more or less a goal out there that we probably never will achieve. That's something we can take out for sure. But I think the goal to have that as part of stakeholders, the clusters, was basically something that was present in the original GEP, and that led to the discussion to actually create a CID. Because from my point of view, if we just focus on our own use case, just using an annotation-based approach is not nice, but it's okay. But if we consider to actually make that usable for others, so for shoot clusters, then a CID-based approach is, from my point of view, much more relevant, because we actually want something that is easy to use, where people don't shoot themselves in the foot. So I think from that perspective, I like it better to actually clearly state that's not the first step we do, but that's basically something we want to do next. So therefore, from that perspective, I liked it that it was in the document, that it was part of the discussion, because as said in the initial discussion, the previous discussion, we had conflicts because of that. And if that was left out, it was basically, it would have been, from my point of view, a little bit of a different discussion. But summarizing, I think,
because it's makes so the shoot thing that you were mentioning. I mean, it's a non-goal for now, and it's of course something that we might eventually want to offer. But in this slide, the thing that Tim proposed, trying to bring these metrics upstream in the support of the metric server would actually benefit to that, right? Because we have a metric server in the shoots. And so it's maybe something we indeed should do if we want to move on to offer this for the shoots in the second phase, because then we don't need to think about where are these metrics coming from.
Yeah, absolutely. I was just, I mean, from my point of view, it was just like, I would not throw it out of the document completely, because I think it's important to have that as context, as something that we eventually want to do. With the downscaling, it's something that we don't really want to eventually do. At least that's my understanding, unless it's really, 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 really needed, because it's difficult. So therefore, yeah, that's kind of my understanding, and I think it makes sense like that.
I think it's fair in this slide to state that implementing it for shoots is for now a non-goal, but a goal is to keep our options flexible and make it easy to use for future use cases then.
Yes. So also from my side, overall, it's good.
Yeah. And then maybe I say also a few words. I liked the proposal already yesterday. I immediately felt at home because I know VPI also very well. So this felt like the right API. There were some concerns yesterday, only in case of what happens if something goes wrong. We will find out over time, I guess. But overall, I like the proposal very much.
Okay, so as for the decisions and meeting minutes part that we also want to publish on the website, I think one main decision was the seed setting discussion, moving this into the provider extensions directly, right? So the setting will be minimal. Then we had this discussion about the eviction strategy that we will not implement, but just rely on the kubelet behavior or kubelet condition presence. Yeah, then another thing was this upstream proposal for the metrics and the metric server that we should open at least and see what the feedback is. And then there were a lot of things that should be somehow mentioned in the doc. I will post them. I made some notes along the way. Things we discussed that are. Yeah. Anything I missed that we should also add? Nope. Cool.
Sounds good for me.
Then, any final words, any final feedback whatsoever before we close the meeting?
Looking forward to the component in action.
Yes.
Great. Okay, then thanks for presenting and thanks for the extra time. And yeah, have a nice day. See you soon.
Thanks.
Thank you.
Thank you.
Bye-bye.
Thanks again for the feedback and bye-bye.
Bye.